Hello everyone. Let us get started with C++ certification training. So we are going to look at STL algorithms and iterators. Now the topics that we are going to cover are as follows. What are STL algorithms? Implementation of STL algorithms. Type of STL algorithms. What are STL iterators? What are the type of iterators? And finally, implementation of iterators. So what are STL algorithms? Let's begin our discussion with that. So what is an algorithm? Algorithm are procedures that are used to process the data contained in the container. So we know there are number of containers that are available in C++, vectors, list, and other containers are there, right? So algorithms are basically functions procedures which work on the data which is stored in the container. So STL provides more than 60 standard algorithms to support various kinds of operation, right? Now algorithms are implemented by template functions. So we have already seen what are templates. So basically the benefit of using template is that the algorithms are independent of data. They can work on any data type. And they are used for tasks such as searching, sorting, copying, etc. There are a number of operations you can perform with the help of these algorithms. The use of algorithms help in saving a lot of time and effort by using the same procedure on multiple types of containers. So as we had seen in a number of discussions with respect to STLs, that we tend to write a algorithm and that can be used on different types of data. For example, if you want to swap two numbers, it could be any data type. It could be two integer or two user defined class objects, or floating point numbers can be there, or character can be there, right? So that's the use of algorithms. So let us look at this example, implementation of STL algorithms. So let us consider the following example and try to implement binary search. Without using STL, you will have to write good amount of code, as you can see. And if you write it from scratch, you might end up doing some mistakes, or you might end up in some kind of a problem if you have to code this yourself over and over again, right? So here the function works only if the array is an integer. So one restriction is that this is working on a integer data type, as you can see here, right? Whereas if you make use of STLs, basically if you want to do a search here, which is a binary search, you simply specify the first element, the last element, and the value that you want to search. So these are the values of the container, first and last, and this works for practically all the data types that are available, right? So this way we tend to make use of STL algorithms, which improves efficiency and saves your time. Now let us look at various types of algorithms. There are various types, or they can be categorized in the following types. You have non-modifying algorithm, modifying algorithm, numeric algorithm, sorting, and relational. So let's look at each one of them in more details. So first, non-modifying algorithms. Let us have a look at few of non-modifying algorithms. One of them can be count, one can be search. So what this does is it counts the number of elements in a given range. For example, you have a container and you might want to find out the number of elements, right? So it will give you that count. This one will search for the specified sequence in a given range. So basically these are some of the non-modifying algorithm, means it does not modify the underlying container in which the elements are stored. Now what I'm going to do is I'm going to point you to this reference link here. This contains details of various kinds of algorithms that are available, and I'll be discussing different algorithms with this reference links. So let me bring up this link and show it to you. So if you look here, these are algorithm libraries. There are different kinds of algorithm. Non-modifying is there, modifying is there, right? Partitioning is there. I mean, covering all of this is really out of the scope of this discussion, but as you can see that there are good number of algorithms which are available for you to try out and play around with, right? So therefore we are looking at few of or subset of these algorithms which is specified in this documentation here, and we'll also try out few of this as a coding exercise in some time. Similarly, we have some modifying algorithms. Some of the modifying algorithms are fill and generate, remove, replace. For example, remove, it deletes the element having a specified value. Replace, it replaces the element having a specified value. So you can reverse, you can do swap, you can rotate, you can find a or rather you can reverse the content of a container, right? So there are these are known as modifying algorithm, meaning that it modifies the content of the container on which this algorithm is basically applied. Then we have numeric algorithm like accumulate, adjacent difference, inner product, partial sum. So for example, accumulate it sums up all the values of elements in the range. Adjacent difference will produce the difference between two adjacent elements. So these are numeric, where you are performing some kind of a operation with respect to numeric operations, like accumulation is addition, adjacent difference is finding the difference. Then we have inner product, it produces the sum of product of a pair of sequences. Then partial sum is there, it produces the sum of subrange of a given range. So suppose if we have a range of numbers, you can take a subset of that range and then find the sum of that sub range in that given range. So we are going to try some of these examples in some time, but this is also known as numeric algorithms, as you see in front of you. Then after that we have sorting algorithms. So what are sorting algorithms? We have sort is there, it sorts a given sequence. For example, binary search, it conducts a binary search on a sorted sequence. Then you have equal range, it finds subrange of an element in a given range. Lower bound is there, then upper bound is there. So it finds the first occurrence of a specified value in the given range. Upper bound, it finds the last occurrence of a specified value in the given range. So basically these are sorting algorithms where you try to perform various operations on the container by applying this sorting algorithms. Then we have some relational algorithms, meaning relational meaning that when you compare one value with another, for example, you can check for equality, equal is there, it checks for equality. Then lexicographic compare is there, where you compare character by character comparison, you perform, that is a lexicographic comparison. Then you can find max, it gives max of two values, max element, it finds the maximum element in a given sequence. So this is out of two, this is in a sequence or in a container. If you have number of elements, it will find the maximum of that. This will find minimum of two. This will find minimum out of a sequence. Then it will find mismatch. It finds the first occurrence of mismatch between elements of two sequence. So this particular kind of algorithms are algorithms where you have relational operation performed, comparing one with another to perform this kind of an operation. So these are some of the algorithms that are available out of the box, or the libraries are available, or the rather I should say functions are available, and you can apply these algorithms on the elements which are stored within the container. So now let us look at what are STL iterators. Now what are iterators? Iterators are similar to generalized pointers and are used to access element of a container. So basically iterator is, as the name suggests, you iterate through the elements of a container and access those values or elements. So iterators are responsible for connecting the algorithm with the container and enabling the algorithm to manipulate the elements in the container. So basically we have talked about algorithm. Now for that algorithm to work on the underlying content in the container, you need to have an iterator. So iterator is basically used to traverse the content within a container. So for example, let's say if this is your container, a list maybe, or a vector which is storing elements A, B, C, D, A, B, C, D, right? Iterator is like a pointer which is pointing to the elements. You traverse them one by one and access those elements and perform the necessary operation or apply the algorithms that we have talked about. So we have input iterator, output is there, forward is there, bidirectional is there, and random access iterator is there. So let's look at each one of them in more details. So let's look at input iterator first. This iterator reads or accesses the element of a container but is unable to modify the elements of the container. So this is just for performing the read operation. For example, you want to traverse the element of a vector or a list, or maybe for other container which is in which you have stored the data. So you can just traverse it. That is done with the input iterator. Then we have output iterator. This iterator supports the exact opposite functionalities of input iterator. It is used to modify the elements of the container, but it cannot read the elements from the container. So as the name suggests and as the description explains, it is used to modify or alter the content of the container. Then you have another iterator which is forward. This iterator can modify the elements of a container in addition to accessing them. Then bidirectional iterator, this provides all the features of forward iterator and can move backward in the container. So suppose you move in a direction where there are elements A, B, C, D, right? So you traverse from A to B, B to C, C to D, right? So this is moving in forward direction. Now bidirectional iterator lets you even traverse back also. So you can move from A to B and back from B to A. So it is known as bidirectional iterator. Then we have also random access iterator. This iterator supports all the features of bidirectional while providing random access to an element at an arbitrary location. So if this was a list again, let's say having A, B, C element, and let's say there is one more element D, then with random access you can directly go to any element, let's say C directly, without having to go to A, B and then C. So you can randomly access any element within the container with the help of a random access iterator. So depending upon your need and your requirement, whether you just want to traverse in one direction or in both the direction, or perform some delete operation, or want to do random access, you can choose from one of the iterators and apply the algorithms on the elements of the container. So this is a small implementation of iterator. We have already seen this implementation of iterators in details in vectors. So here what we do is we define a container type, parameter list, and then the iterator and the name of the iterator. So if you will see here, we have defined a vector. This is a vector we are using with integer data type, and this is the iterator, and this is the name of the iterator, which is I. So it is pointing to the beginning of the element, and this is end of the element. So basically, if you draw it in a diagram here, it is like this: 1, 2, 3, and 4, right? Now initially I begin points here and I not equal to Vn. So one by one you traverse here, here, here. So every time you say star of I, it fetches this element here, then it goes back in the loop, and when you increment I plus plus, the iterator moves from 1 to 2, then 3, then 4. So this keeps on happening until it doesn't reach the end of the iterator. So this way you start traversing the content of this particular container, in this particular case a vector, and access the elements using an iterator. So basically in the above example, the iterator is used to traverse. Iterator is an I represented by I, is to traverse the vector V and print each element present in the vector. So this is a simple one directional traversal that we are trying to perform on a vector container. So to summarize the discussion, at the end of this session, you should be able to understand what are STL algorithms and understand the various STL iterators that are available in the library. So to summarize, we have looked at what is various implementation of STL algorithms, what are the different types of algorithms that are available, what are the different iterators that are there, and how we can make use of different iterators, whether it is a input, output, forward, bidirectional or a random access iterator. That's all in this discussion. Thank you so much for your time.